Hi, welcome to our major assignment, and we are from group MCG3, and our group members are Asad, Shamila, Shashanika, Navoda, and Prabodhi. And our lecturer is Dr. Akanksha Sharma, and our tutor is Dr. Moshe Chaudhary. So let's start and get along with our major assignment.
This project simulates migrating core business applications, especially ERP and CRM systems, into scalable and secure AWS environment. The goal is to ensure improved performance cost effectively and high availability while maintaining hybrid cloud structure for legacy integration. Although we were simulating the hybrid setup, we will demonstrated how a real site-to-site VPN would be established. A virtual private gateway connected the AWS side of the network. A customer gateway simulated the on-premise environment with the placeholder IP. The VPN connection is configured with static routing to represent ACME corporate network. This step is crucial in hybrid architecture to bridge cloud and on-premises systems. The design starts with the custom VPC named ACME Cloud VPC using a private CIDR range for secure internal networking. I will segmented the infrastructure into three subnets: a public subnet for the Western host and a net gateway, a private app subnet for the CRM application, a private database subnet for ERP backend. This logical separation enhances security and allows for future scaling. In this phase, we focus on simulating a functional ERP and CRM setup on AWS. For the ERP system, we uh, provisioned a MySQL database using Amazon RDS. It's placed in the private subnet to enhance security, and multi-AZ deployment ensures availability. The CRM system is simulated on an EC2 instance using the Western HOTS to manage static data like backups and logs. We use Amazon S3. It supports versioning, um, provides a scalable storage, and has access control to ensure sensitive data is protected. Overall, this setup mimics a real world deployment while remaining within the AWS Academy constraint.
Hello, I'm Nauda Lankeshi. In this part of the project, I was responsible for ensuring scalability and high availability for the hybrid cloud network used by Acme Manufacturing. To achieve this, I started by creating a custom VPC with both public and private subnets distributed across multiple availability zones. This multi-AZ setup in achieving fault tolerance and network redundancy. Next, I launched two EC2 instance, placing each one in a separate public subnet in different availability zones. This instance simulates with web servers. To manage income traffic, I configure an application load balancer within evenly distributed the load between the EC2 instance. This is not only improve performance but ensure the application remains availability even with one instance fail. Finally, for the backend, I try to develop a Amazon RDS MySQL database with multi-AZ deployment. This ensure high availability and automatic flavors in case the primary database instance goes down. In here, the focus was on creating a cost-effective cloud architecture. To stay within the budget, I use free trial instance types, especially T2 micro and T3 micro for both EC2 and RDS resources, and also implemented Amazon S3 lifecycle rules. For the cost monitoring, I created a budget alert and in the AWS budget and the cost explorer to track usage and spending. A budget threshold ensure the usage stayed within the free trial and avoid unexpected charges, and also use auto scaling. These are the AWS tools and services I used: Amazon EC2, Amazon VPC, Application Load Balancer, Amazon RDS, Amazon S3, and AWS Budget. In summary, through the use of AWS infrastructure services and best practices, I be able to design a hybrid cloud solution that the both is scalable and cost efficient. The configuration ensure the high availability and through the multi-asset deployment and traffic distribution, while also minimizing the expenses by leveraging free trial resources, lifecycle rules, and cost monitoring tools. These solutions align with the enterprise cloud standards and meets the objective defined in Part C and D of this project.
Hi, I am Shashinika. I am here to present about security measures and monitoring measures for the hybrid cloud. First of all, I will describe about security measures. In designing security measures for this project, I categorize the security design into five main parts. It's like security measures for network connection, VPC design, EC2 instance, RDS database, and for S3 bucket. It is mandatory to establish a secure network connection between on-premises and cloud network. For that, there are two ways to establish a secure network connection. One is secure IPsec encrypted VPN tunnel or dedicated private network link. In AWS, we can use Direct Connect, which is a dedicated private network link. This is a summary about the security measures for each VPC design, EC2 instance, database, and S3 bucket. When designing the VPC, I used security measures like editing routing tables, creating security groups, and adding network access control list. For all the other resources, each resources must be assigned to a private subnet in the VPC. It is the major security measure in launching these AWS resources. In addition to that, for EC2 instance, I used latest AMI, then created SSH key pair, created security groups, and encrypted EBS volume. For database, also I created security groups, added network access control list. In addition to that, included certificate authority, RDS storage, encryption, and enabled database monitoring tools for further monitoring and securing of the VPC of the design. For the S3 bucket, I denied public access, then enabled bucket versioning and encryption. Encryption is done using SSC-SC or else we can use SSC-KMS. This is the final part I have to describe. It is about hybrid cloud monitoring. For both AWS and on-premises environments to have high availability, security, and performance, the hybrid cloud network must be effectively monitored and managed. For that, there are different tools in AWS environment: CloudWatch, CloudTrail, AWS Configs, and VPC Flow Logs. For this project, I basically use VPC Flow Logs and CloudWatch. VPC Flow Logs is a powerful AWS feature. It captures information about the IP traffic going to and from the private interfaces within the VPC, private and public, every interface. Amazon CloudWatch is an observability and monitoring service. It offers up-to-date information about AWS services, apps, and resources.
Thank you, Shashnika. So we are coming to the end of the first part and the beginning of the second part. So second part is AWS CloudFront implementation. This section is doing by me and Asad. So let's move on. The first section was to create a CloudFront distribution and to configure it. And this can be used as a web content stored, and we're using Amazon S3 buckets and using HTTPS encryption. This solution also have a content distribution which can use to improve performance and also to deliver web applications in the AWS Academy environment. So what is the key components that we're going to use? If I'm going to talk about it a little bit further, if this is going to further analyzing, the Amazon S3 bucket is serving as the origin server, which is consists of storing web assets, cloud distributions layer that provides global caching content, that working as a CDN layer, while SSL and TLS certificates, you guys know it, which can enable the HTTPS encryption as a default certificates. So as you can see, Amazon S3 is going to use, Amazon CloudFront is going to use, and HTTPS or SSL certifications going to use. This data is flowing from user requests to originate from the CloudFront domain, and it also checks the edge cache on content request afterwards. If the cache is going to miss, CloudFront can retrieve the content from S3 origin. Afterwards, the content is cached at the edge and the location, and the server can be originated to the user. And let's move on. So I'm going to talk about this photo which I have tried from my AWS Academy platform. This is a creating bucket which I named as Acme Web Content MCG3, which is our group name. You have to go to the services and you have to select Amazon S3 and you can see this page. So after that, you have to go to the create bucket section to the general configurations. You can see the naming that I have done that I told in the last slide. Uh, Moving on, and here we go. Here I got an error message. If you can clearly see, I do not have the full authorization to perform or create the S3 bucket. That means it is failing in the first section, which means that I cannot proceed without creating the S3 Amazon bucket because we're having a limited student subscription. Uh, Anyway, I'm going to talk about how we can do if we created that S3 bucket. This, as you can see, we have to configure using public origin access, which I already have done in the when creating the bucket, and also we have to configure HTTPS or HTTP, and we can choose the default CloudFront cachings and also the CloudFront.net certifications as well. Moving on to testing and validation section, this is all monitored and deployed in states when it is achieved. CloudFront domain can be used to obtain and should conduct end-to-end testing through HTTPS protocols, and also it has to be verified. And if we're moving on, when it comes to the security considerations, the CloudFront is integrating with S3 Amazon Bucket, which is consistent with security, like a lot of security layers, and it is protected very securely because it's using HTTPS encryption forms, and also it is consisting with SSL and TSL protocols. And also these encryption methods can be used to protect data from interception by providing end-to-end security, which is really.
Hello, today my presentation topic was AWS. First of all, we discuss about security measures. Security measures include then WAF Web ACL. Then that's the performance Then HTTPS and TLS. That's the performance of HTTPS and TLS enforcement. Then body is monitoring and optimization. Then CloudWatch dashboard. CloudWatch dashboard means that's the CloudWatch dashboard performance we performed in our. That's the summary and next step how to perform and sum up of our